Okay, so this is my video of subtracting rationals. When we have two rationals, we never actually subtract. Okay, what we want to do is we always want to distribute the negative sign. And turn it into a plus sign. Okay, so what's happening here in this example number one, right? See how it's 4 over x minus 5 minus 2 times, or 2 divided by x plus 3. What happens is I'm going to change this minus symbol into a plus symbol, and that minus symbol I'm going to distribute to that 2. So now that becomes a negative 2. So now it's just like addition. And just like addition, we have to find our least common denominator or divisor, our LCD. So in this situation, notice that the divisor, x minus 5, that's the total divisor, and x plus 3, that's the total divisor. Notice they're missing pieces, right? On this side, it's missing the x minus 5, so I'm going to multiply the top times x minus 5, as well as the bottom times x minus 5. That tells me that my LCD is actually equal to x plus 3 times x minus 5. So that's what my LCD is going to be. So because I multiplied this side times x minus 5, now I have my LCD here. But notice on this side, I'm missing the other piece as well. Well, I have the x minus 5, but I don't have the x plus 3. So I multiplied the bottom times x plus 3 and the top times x plus 3. Okay, now I have my LCD here. See? X plus 3, x minus 5, x plus 3, x minus 5. So now after we do this, we just distribute and we add. So we have our LCD, which is on the bottom, which we said was x plus 3 times x minus 5. Okay, and now we're going to distribute this 4, right? So what I'm going to show you here, this is the whole piece, is 4 times x plus 3 plus negative 2, right? See how I distribute that negative 2? Times x minus 5. So I'm just treating this as addition. So now I distribute, right? 4 times x times 4 times 3, right? So that gives me 4x plus 12. Okay. Plus negative 2 times x is a negative 2x. Negative 2 times negative 5 is a positive 10. Okay. All of this is over our LCD, which we said was x plus 3 times x minus 5. Okay, now in this case we combine our like terms. I have 4x here and a negative 2x here. When I combine those, that gives me a positive 2x. So I'm going to draw my arrows where I'm going from here to here, back to here. All right, so 4x and a negative 2x combined to give me 2x. 12 plus 10 gives me a 22. So that's 2x plus 22 over x plus 3 times x minus 5. Now, we could take a GCF off on the top to reduce this just a little bit more, but nothing's really going to cancel out. So if I take the GCF of 2x and 22, that's actually 2. So this would give me 2 times x plus 11 over x plus 3 times x minus 5. And that technically is your final answer. It's simplified completely. So that's how that looks. Okay, so that's the first example. Your second example, again, we're subtracting, but really we're not subtracting. We're just going to distribute this negative symbol here to this 4. And then that becomes a plus. So now that's a negative 4. Now we have our tops and our bottom. But now you'll notice here on the bottom, x squared minus 1. Well, this is something that has to be factored because it's going to give me 2 factors. Okay. Thankfully, this is perfect difference of 2 squares. So this actually becomes x plus 1 times x minus 1. Okay, and we kind of get rid of that denominator there. Now I want to show you something, so hopefully we start to understand LCD a little bit more. Right? LCD here is what's missing. Here I have x plus 1, x minus 1. Here I have x plus 1. So what does that mean? That means I'm missing an x minus 1. So that's what I need to do. I need to multiply it times the top and the bottom. Now, the reason why I'm doing this is because this is technically 1. So I'm not really changing this number. I'm changing the way it looks. Because x minus 1 divided by x minus 1 is 1. Right? So that's why we're doing the bottom and the top. So my LCD here is x plus 1 times x minus 1. And that's what should be in the denominator, right? The D in LCD stands for denominator or divisor. Okay. Now, when we look at this 2x, I didn't have to do anything with this 2x because it has the whole entire LCD. So I'm going to leave that alone. So it's going to be 2x plus. Okay. But now I have this negative 4 that I need to distribute. So plus negative 4 times x minus 1. And again, this is all over my LCD, which was x plus 1 times x minus 1. Okay, so I'm going from here to here. Okay. Distribute my negative 4. Okay, and this gives me 2x minus 4x plus 4. Okay, I'm kind of just skipped the step that I didn't do on the top, but hopefully you can see it. And again, this is over my LCD, so I'm just going to type the letter LCD just because I don't want to rewrite it all again. Okay, now I combine my like terms, 2x and negative 4x. That gives me a negative 2x plus 4 over my LCD, right? Which we said x plus 1. Okay, so now I'm going here. But guys, look, I can also take out a negative 2 here, my GCF, right? So when I take my GCF, I'm going to take out a negative 2, right? Just make it nice and neat. So my final answer, and we're going this way, when I take that negative 2 out, I'm going to have negative 2 times x minus 2 over x plus 1 times x minus 1, which was my LCD at the beginning, right? Okay, now unfortunately nothing else can really simplify here or cancel out, so that's what we're left with. Okay, so we're good there, good to go. All right, example 3. Example 3 looks a little bit different. You'll notice that there's not a binomial here. These are only monomials. I have a 5x here and an x here. Well, they both have an x, but they're missing a 5. So this piece right here is missing a 5. Okay, now be careful. I'm going to distribute a negative 1 as well because I'm changing that. So remember, when I distribute this negative 1, I got to distribute it to everything in there. Okay, so my LCD for this one, and let me use the other pen. For this specific problem, my LCD is going to be 5x, right? Okay, well this has 5x, so I don't need to do anything with that. So that's x plus 1, okay? Plus, and I'm just going to put that plus there because again, remember we're treating it like addition. Well, here I need to multiply this times 5 over 5 so that I have 5x on the bottom. It's my LCD. Again, 5 times x is 5x. This gives me an LCD that's common. That means I can add the top completely. Now what I do to the bottom, I have to do the top because 5 divided by 5 is 1. And that's what we're trying to do, guys. 5 divided by 5 is 1, so really I'm not changing this number. I'm just manipulating it so that it looks, so that I can add the numerators together. Okay, so remember we have negative. So technically, negative 1 and 5 is what we're distributing. So we distribute, right, and we distribute, right? So technically I'm distributing negative 5. So you're going to see this. Plus negative 5x plus 15. Okay? This plus comes from the original addition problem that I have here. You'll notice that this is a negative 5 times x. This is going to be negative 5x. Negative 5 times negative 3 gives me a positive 15. Okay, all of this again is over my LCD, which is just 5x. And that's easy to write, so I'm just going to go ahead and write it. Okay, and then I combine my like terms x and negative 5x. X plus negative 5x gives me a negative 4x. But guys, that's the only thing I need to combine. Now I have a constant. I have a 1 and a 15. So this gives me 1 and 15. That gives me 16 if I combine those two together. So plus 16 over 5x. Okay. Now again, we can take the GCF out here. Once I take the GCF, and we'll say negative 4. So if I take a negative 4 out, that leaves me with x minus 4, right? Negative 4 times x, negative 4x. Negative 4 times negative 4 is positive 16 over 5x. And there is my final answer for this example. Feel free to pause or slow down at any moment, since maybe I went a little too fast. But hope you guys are having a good day. I just want to remind you guys that I miss you very much. You guys were the highlight of going to school. I love my Algebra 2 classes. You guys are awesome, and I miss you guys so much. And I really hope that you guys are doing well and staying safe and healthy. Until we see each other again, y'all have a good day.